Hey guys, so we're going to continue our discussion of double angle identities, and this time we're going to use double angle identities to find exact values. Um, so we'll start out with something like this. We'll be told that cosine of x is something like negative 2/3, and that my angle lives somewhere. Okay, so it lives pi over 2 to pi, which means it lives in quadrant 2. Okay, so and we want to find sine of 2x, cosine of 2x, and tangent 2x. Okay, so in order to do that, I need to look at my formulas and see what I need to find. So I have cosine, but I need sine, and tangent would also be nice. So the first thing I'm going to do is I'm going to draw myself a picture. Now, you can use the Pythagorean identity to do this. I just find it a little bit more difficult to do it that way. So I prefer pictures. Pictures are good. Okay, so quadrant 2 is on the upper left-hand side. So I'm going to draw my triangle here. So cosine I know is adjacent, negative 2 over hypotenuse, like that. All right, and now I'm going to use Pythagoras to help me find my missing side. So I'm going to go negative 2 squared plus b squared is equal to the hypotenuse squared. So that's 4 plus b squared, 9b squared is 5. So b is the square root of 5. Now I know that it's going to be a positive square root because it's up, going up on the y. So square root of 5. So now I can find sine. Oops. And that's going to be opposite over hypotenuse. And tangent, which is going to be opposite over adjacent. Okay, so now I have everything I need. So I just look at my identities. So sine of 2x is 2 sine x, then cosine x. Get rid of these. Okay, so if I plug those in, I get 2 radical 5 over 3 radical negative 2 over 3. Okay, so that's going to give me negative 4 rad 5 all over 9. And that's it. So cosine. Now notice that cosine has like 3 different forms. So you can actually choose which one you want to use. Let's say I don't want to deal with radicals today. So I would go for the third one. So 2 times a negative 2/3 squared minus 1. So that's going to be positive 4 over 9 minus 1. So 8 over 9 minus 1. If I do common denominators, I get negative 1/9. Okay, now tangent is an interesting function. So we're going to do a little experiment while we have you here. So tangent of 2x is 2 tangent x, 1 minus tangent squared x. Okay, so I'm going to go ahead and use that formula. So 2 radical 5 over a negative 2 1 minus radical 5 over negative 2 squared. Okay, so if I simplify that on the top, my 2 and negative 2 will divide out, and I'm left with a negative radical 5 on the top. On the bottom, I have, let's see, a radical 5 squared, that's just 5. Negative 2 squared would be 4, so negative 5 fourths. Okay, using a common denominator. So that would be 4 over 4 minus 5 fourths. Negative square root 5, negative 1 over 4. Invert and multiply. We get positive 4 radical 5. Okay, so let's see if this works. I know that tangent is sine over cosine. So let's try. Let's see if it's easier. It might not be, but let's see. So I know that sine of 2x, in this case, is equal to negative 4 radical 5 over 9. And I know that cosine of 2x is equal to negative 1/9. If I invert and multiply, negative times a negative is a positive. The 9's divide out, and check that out. Pretty nifty, huh? Okay, so that's how you use the double angle identities to find an exact value. Okay, all right. Thank you for watching.